Good afternoon, grade 11 geography learners. This afternoon we will be doing map work. But before we get started, let me first introduce myself. I am Mr. Regan Ford from Belgravia High School, and I'll be teaching you this afternoon. And I would also just like to take a minute to tell the learners of Perseverance High School in Belhar that we are all thinking of them at this moment. They lost their geography teacher last week, Mrs. Astrid Brown, who, after a long illness, was taken away from them. So our condolences to all the geography learners at Perseverance High School. We are thinking of you, and we know that you are going to make Mrs. Brown very, very proud in your final exam. Thank you. So, map work. Usually in map work, we look at calculations. But today, our focus is not going to be on the calculations, but rather on the interpretation of the map. So, let's get started. As you see on the slide in front of you, that our ultimate aim is to prepare ourselves for the grade 12 Mapwork exam, which you will write in about a year's time. And on the slide, you can see all the bricks making up the wall that you've been climbing since grade 8. We need to do map reading, cross-sections, map skills, contours, GIS, orthophotos, map symbols, etc., etc., etc. And all the bricks on the wall constitute the work that you need to know for your grade 12 final Mapwork exam. And I would estimate that you are more than 80% of the way there already. So, paper 2, geography, paper 2, Mapwork. What does your question paper look like? It is out of 75 marks. Your first question will consist of multiple choice questions. The MCSQ stands for multiple choice short questions. 1 mark questions, and you will receive 15 of them. Take your time when answering these questions. Very often, the answers to these questions can be found in the key of the map. Just have a look at the bottom or on the side of the map. Have a look at the key. Try to eliminate. When you have 4 options, first of all, figure out which one is definitely incorrect. And then you find the 1 or 2 that are definitely incorrect, and you've already reduced your chance, you've already increased your chances from 25% of getting a correct answer to 50%. And then once you have 2 options left, now you've got to use what you have been taught in the class to get to the answer for that multiple choice question. So the multiple choice questions make up 15 of your 75 marks. Then your map skills, which we looked at in our last lesson. Here, you will be asked up to 25 marks. And you know the skills that you need to know. We're not going to be looking at them today, but just to recap them quickly, you need to be able to calculate distance, you need to be able to calculate area, you need to be able to determine intervisibility, calculate gradient, etc., etc. You know all the skills that are required of you. And that's usually about, as I said, 25 marks. The section that we are going to focus on today, application and interpretation. So in grade 11, this means we're going to be looking at climate, we're going to be looking at geomorphology, and we will be applying what you've learned in those sections of the work to map work. So you will be asked questions on those sections in your map work paper. So remember, map work, once again, is not just about calculations. You also need to be able to explain some of the content of your theory work in the Mapwork paper. And as I said, that is going to be our focus today. This section is usually worth about 20 of your 75 marks. So you now have 15 for multiple choice, 25 for the skills, and 20 for the application, which gives you 60 marks. Your final 15 marks in your paper comes from the GIS section of your work. Right. When you have a map in front of you, remember, a map is not reality. It's not a photograph. You can't see exactly what is on there as it appears in reality. You are seeing an interpretation of reality. You're seeing a lot of symbols, a lot of lines that represent reality. And you have to make sense of these symbols, these lines. And therefore, you need to create a mental image. When you look at the map, you need to create a mental image in your head of what this area actually looks like in reality. And I'm going to help you to with a few pointers as to how to go about creating that mental image. Right. The first thing that you will notice on your map is the use of color. Now, in addition to having symbols and lines and various things on the map which show us what reality actually exists in this area, colors also help us. So, the first color we're going to look at is brown. And brown is usually used to show relief. In other words, the topography of the area. You've been using contour lines since grade 8. You were introduced to contour lines, very simple contour lines in grade 8. And now by grade 11, you know already that the contour lines can tell us a lot about the relief, the topography of the area, where slopes are steep, where slopes are gradual, which landforms are found in the area. And by looking at the brown section of the map, we can get a very, very good idea of the shape, the topography, the lie of the land. Blue, obviously, will show us drainage. In other words, water. We will see rivers, lakes, dams. Any element on the map that contains water will obviously be in blue. Red and also black is used to show various types of infrastructure, especially roads and railway lines. The two symbols which are indicated on the slide at the moment are there's a national road and there is a railway line with a station affixed to it, right? So red and black to show infrastructure. Power lines would also be in black, etc. The gray color is used to show human settlement. Now, you know, if you look on the slide, you see the little black blocks in that white area there, the little black blocks over here in the white area, and these are buildings. But we also know that when there are too many buildings in an area, to illustrate them using blocks, we shade the entire area gray. And that shows you that there are many, many buildings. That would usually be a town or a city, a human settlement. The green would show us economic activities, more specifically primary economic activities. The two symbols that you see on the screen in green, the top one is the symbol for cultivated land. You know this already. This is one of the more common symbols that we use. This means that crops are being grown. And then the other green symbol is the symbol for orchards and vineyards. This is an indication that there is fruit farming taking place in a particular area. There are obviously many, many other green symbols as well. You don't have to remember all the symbols. Remember, the symbols that you need to know, the more important ones, will be on your map. Right, let's move on. Let's have a look at an actual map on which we can see the various colors that I have just referred to. Let's look at the brown. This is the map of Ceres. And we can see in the eastern section of the map, in other words, to the left, the eastern section of the map, I can see a host of contour lines. What can I tell from these contour lines? I can see in this area over here, close to Pine Forest Holiday Resort, that the contour lines are extremely close to one another, which suggests to me that this slope here is extremely steep. I can see the top of the peak here. There's a spotlight showing me that this area is 912 meters above sea level, and I can see Ceres Peak with the Trig Station 98 atop of it at a height of 1,204.2 meters above sea level. So the brown lines here, the brown section of the map, shows me the topography. On the western side of the map, I hardly see any contour lines, hardly any brown, which suggests to me that this area is relatively flat. Let's move on. What do you see now? Blue. Here is a river flowing through Ceres. I can see the river. I can see various farm dams. Notice the farm dams. Notice the river. You could be asked to explain in which direction the river is flowing. Sometimes in the question you'll be told this river is flowing in a particular direction. give reasons why this is true. Or you could be asked, in which direction is this river flowing? Give reasons to support your answer. And your teacher would have taught you the various ways of ascertaining in which direction the river is flowing. Usually, we would look out for contour lines, we would look for spot heights, etc., to determine in which direction the river is flowing. Right. There's red and black. And we said earlier that this is infrastructure. Over here, I can see a road, 2 roads running through Ceres in red. This black line here is the railway line. Just as a matter of interest, notice how the railway line and the road go through the mountain exactly where the river has carved a path through the mountain. This is a mountain pass. The name isn't present here, but we know, those of us that go to Ceres on a regular basis know that this is the Mitchell's Pass going through the mountains into the town of Ceres. The grey area, what did we say earlier? The grey is our built-up area. That is our settlement, our human settlement, because there are so many buildings here, we shade the entire area grey. We don't just show individual buildings as little black blocks, because there would be too many of those little black blocks for us to show. And then lastly, the color green. And we can see that Ceres is a farm area, lots of primary activities taking place. And when we look carefully, we can see that there are a few cultivated lands. The main activity is fruit farming. How do I know that? Because of all the orchards and vineyards present on the map. And then also over here on the northwestern side of the town, we can see a little bit of a forest here, right? This is a forested area. Notice also the rows of trees. We're going to refer to it later. Notice the rows of trees between the orchards and between the cultivated lands. Later on in this presentation, we're going to look at the function of those rows of trees. So now I have a better idea. I had the map before I even started answering the questions. I looked at my map and I tried to create a mental image of what was happening on my map. Right. Now, here's a map showing you the area around the Voelvlei Dam. And a typical exam question relating to a dam. For what purpose, or for which purposes in plural, excuse me, is the dam used? Now, grade 11s, you need to be very specific when answering the question. Often, when I'm marking a question like this, learners would be very vague, and I would receive answers like the dam is used for water. I cannot award you any marks for that. The dam collects water. I can see it on the map that there's water in the dam. But that is not what the dam is being used for. You need to relate the water in the dam, or the use of the water in the dam, to human activities. You need to find in and around the area of the dam various human activities to which you can relate the use of water in that dam. So let's go back to our slide and have a look at what is happening around here. Now you would notice that I have 3 headings: irrigation, drinking water, and recreation. Because on this map, those are the 3 purposes that I can identify. Just as a matter of interest, before I go and look for evidence of those 3, a 4th heading that I could have put here would have been the generation of electricity through hydroelectric power, because here are power lines present in the area. There are power lines present. However, I cannot, around the dam, see any evidence of power being generated of a hydroelectric power station. So I cannot use that as a reason, because I do not see it. Let's go and have a look at what we have. So, irrigation. What is meant by the term irrigation? It's useless writing about things if we don't know what it means. So to irrigate means to water your crops. It's as simple as that. If you or your dad or your mom are standing in front of the house with a hose, or nowadays we're very water-wise with a bucket of water, watering our garden, we are irrigating the garden, right? In simple terms, we are bringing, because there isn't enough water falling naturally in the area, we will use our bucket of water to bring water to the plants. And that is what irrigation is. And a farmer does exactly the same thing. He brings water to his crops from the farm dam or from a larger dam. And that is what the word irrigation means. So whenever you see the word irrigation, it is a process that makes up part of the bigger farming process whereby farmers water their crops. It's as simple as that. So let's go and look for evidence of irrigation. Now, when farmers irrigate their crops, the simplest way is through the use of canals or furrows, right? The Afrikaans word, it's a very nice word, a slootjie, where a sloot or a slootjie, where water is led from a dam towards the crops. And let's have a look here. There you will see a furrow and a canal. Okay, a furrow would just be a smaller canal. It's basically an area that is dug into the ground, a long furrow that is dug into the ground, and water can then flow along the furrow or the canal into the fields where the farmer is cultivating his crops. On this map, there are many other examples, but those two are the easiest to find. So I have evidence. So in my question, when I'm answering the question for which purpose is the dam used, I can clearly, categorically state this dam is used for irrigation. And my proof that I'm offering is that there are furrows and canals present on the map, which proves that farmers are using this dam to lead water to their crops. Now, how can I prove that this dam is being used for drinking water? Now, what would the difference be between water that's being used for irrigation purposes and water that I have to drink? I have a glass of water here, which I am drinking. What would the difference be between the water in this glass and the water that's being led via the furrows to the farms? Very simple. If you look at this water, it is clear. There are no leaves in this water, there's no soil in this water, there's no grass. Whichever impurities were in this water has been removed. So, if I want to check if the water in the dam is being used for human consumption for drinking purposes, I need to find some sort of evidence that the water is being purified, that the water is being cleaned. Because the water being led off via the furrows to irrigate the crops, that's fine. If there's leaves in the water, if there's soil in the water, sand, dust, whatever, it's fine. The crops are not going to be affected. But as human beings, our water needs to be clean. So let's go and have a look. Drinking water. Purification and treatment, that's what we're looking for. And if you look on the banks of the Voelvlei River, there is a filtration plant, and further to the south, the Voelvlei water treatment plant. You see that? So the water is first filtered. That's where all the solid particles are removed. The sand, the dust, the leaves, the little bits of grass, etc., that get into the water, any solid particles are removed at the filtration plant, and then the water is pumped to the water treatment plant, where chemicals and other processes are used to remove any other impurities in the water that we cannot see. So I can clearly state that the water in this dam is used for drinking purposes because the water is being filtered and it is being purified. What about recreation? Right? Where we go to relax, to play sport, etc. You can't just say because there's a large mass of water that it is used for swimming or for boating or for any other recreational purposes. You need to find proof on the map. And usually you can find it within a kilometer or two, but nobody's going to travel further than that. So, on this map, there's a hotel. I'm going to show it to you right now. There's a caravan park. And as I said, look in an area, draw a buffer of about 2 centimeters around, right? I'm bringing in a little bit of GIS here now. Draw a buffer zone using your pencil of about 2 centimeters, which will be a kilometer around the dam. And then you'll be able to see these things more clearly. And there's a caravan park, there's the Voelvlei Nature Reserve, there's a hotel, etc. And all of these indicate to me that this dam is being used for recreational purposes as well. So learners, can you see now that map work is not that difficult? When we have to interpret the map, it is not that difficult. All that you have to do is take your time. Look at the particular part. That map is big. Focus on the part of the map that your question relates to. Have a look in the area. Ask yourself, in the case here, for example, the question was, for what purposes is the dam being used? Before you start answering, ask yourself, what could the possible reasons be? What could the possible reasons be? Make a list. Maybe some of your possible reasons are not correct, but make a list on your scrap paper or on the back of your question paper. These are the possible things that the dam could be used for. Now start trying to find evidence for each of those. And if you can't find evidence for any point, for example, earlier I spoke about the dam possibly being used to generate hydroelectric power. I couldn't find evidence to support that, so I couldn't use that point. But I could find evidence to support the fact that the dam is being used for irrigation, it's being used for drinking water, and for recreational purposes. Right, a very common question, and I can guarantee you that you will get this question sometime during the course of this year. If not during this year, you are definitely going to get this question next year in grade 12, whether it's in your June paper, your September paper, or in your final paper. And that question relates to seasonal rainfall or rainfall throughout the year. Now, a little tip. All the topographic maps that we use are maps of South Africa. We use maps only of South Africa. And there are very, very few places in South Africa that receive rainfall throughout the year. Most of South Africa receives seasonal rainfall. So most of the time, when you are asked this question, your answer is going to be that the rainfall is seasonal. So, what am I saying? If you get the question, is the rainfall in this area seasonal? Which means, does the rain fall only during a particular season? For example, we know that in the Western Cape, it rains when? During winter. We know that in the interior of South Africa, rainfall occurs mainly during summer. And that is what is meant by seasonal rainfall. So if you're unsure, if you can't find any of the factors that I'm going to tell you about now, and you have to guess, remember, we don't want to guess. We want to be accurate. But if you have to venture a guess, then the safest bet, if it's a map of South Africa, is that it's going to be seasonal. But we're not going to guess. Why? Because I'm going to show you now how to find out if the rainfall in this area is seasonal or if it occurs throughout the year. Now, let's look at the map. How do I see rainfall on a map? I can see rivers, I can see water masses, I can see an ostrich farm, I see nature reserves, I see roads, I see lots of things, but how on earth am I supposed to tell if it's raining? Now, let's stop and ask ourselves a question. If it is raining, if you live in an area and it is raining, are you going to go out to water your garden? I don't think so. Because if you're standing watering your garden in the rain, your neighbors are going to think there's something very, very wrong with you. And they're going to call the mental health institution to come and have a look at this funny neighbor of theirs watering the garden in the rain. So, if it's raining, we're not going to water our gardens. So if it rains throughout the year, if it's an area that receives rainfall throughout the year, it is unlikely that farmers are going to practice irrigation. Why must I have wind pumps? Why must I have farm dams and canals and furrows leading to the crops to be watered if rain is falling throughout the year? It would be unnecessary. So, if you see lots of evidence of irrigation taking place, then you will tell yourself, myself, irrigation is taking place, so this means that this farmer does not receive rainfall throughout the year because he has to irrigate his crops in the seasons when it is not raining. How else can we tell? Look at all the dams. On this map, I see numerous farm dams. Why would the farmer have to collect water? Why would he have to collect water to irrigate his crops, once again, if it rains throughout the year? So the presence of all of the farm dams on the map tells me that this area probably does not receive rainfall throughout the year. There is an irrigation scheme. Now, on the map, it says besproeiingsskema. You speak English, you do not speak Afrikaans. So how on earth are you supposed to know that a besproeiingsskema is an irrigation scheme? And learners, this is where, at the start of your question paper, remember, on that very first page where you have the instructions, what do you see? What does your teacher always tell you? There's a list of English and Afrikaans. There's a table showing you English terms and Afrikaans terms. So when you look at your map and you see a word in English or in Afrikaans, in your case, because you're all English-speaking learners this afternoon, the learners who are going to tune in tomorrow will hear the opposite side, the flip side of the story, because they'll be Afrikaans learners. So when you see terminology in a language that is not familiar to you, please go to the front of your question paper, have a look at the table which shows you the English and Afrikaans equivalents of certain terms that are used on the map. So there's a besproeiingsskema, or in English, an irrigation scheme. Then, if I look in the southern part of this map, there are many non-perennial rivers. Now, you've been learning since primary school already. A non-perennial river is a river that is not permanent. It only has water in it for a certain part of the year, for a certain time period. That tells me that this area does not receive rainfall throughout the year. Because if it received rainfall throughout the year, every single river would be drawn in a solid blue line. The fact that some of these rivers, if you look carefully in the southern part of the map, you will notice that these rivers here in the south have dashed or dotted blue lines, which means that they are non-perennial rivers. They do not flow throughout the year. So that gives me more reason to believe that this area receives seasonal rainfall as opposed to rainfall throughout the year. Furrows. Ties up with what I said right at the start. Furrows and canals. More evidence of irrigation. Right. So you are now clear. You should now be clear as to what to look for when you are confronted with the question, does an area receive seasonal rainfall, and does it receive rainfall throughout the year? And I think you should all now be clear on what is meant by seasonal rainfall. Rainfall only during a particular season, whether it be winter here in the Western Cape or summer in the rest of South Africa. Right. Now we're going to come to a bit of climatology. Here's a map of the Simonsberg Nature Reserve area, the Simonsberg Mountain. And the question is it warmer at place A on the map, or is it warmer at place B on the map? Now, once again, what is up with these people? I can't see the sun. There's nothing on this map showing me the temperature. So how on earth am I supposed to know whether it's warmer at A or at B? This means that I've now got to go back to my knowledge of climatology. I've got to refer to my knowledge of climatology to figure out which area is going to be warmer. Now, if you look at this area very, very carefully, you will notice that between A and B, there's a trig station number 60, with a height of 1,390.2 meters. Right. And, and I will notice that from A to B, I am actually going, if I were to walk from A to B, I'd be walking up a slope. Notice the contour lines, very, very close together. And then when I get to the top of the hill or the mountain, I'll be coming down the other side. So in other words, all along here at A is one side of a ridge or a mountain slope, and this is the other side. The highest point would be here along the middle. I see on the WhatsApp line that Mr. Williams from Kensington High is greeting us. Welcome, Mr. Williams. And let's get back to our slide. That is the ridge that I was speaking about. There is the top of the ridge. Now that I've drawn in, please don't you go and draw red lines on your map. Your teachers are not going to be very, very pleased. But once you've identified where the high-lying area is, now things start to become clear. Because I can now see that one side of this ridge is facing in a northerly direction. The other side of the ridge is facing in a southerly direction. And all of a sudden, something that I learned in grade 10 starts to come back to me. Let's have a look at that slide again. Side A is facing north. Side B is facing south. I know that this is in the southern hemisphere, Simonsberg. It's here in the Western Cape. And what did I learn in grade 10? That slopes facing north receive sunlight for most of the day, while slopes facing south do not receive that much sunlight. They are in the shadow zone. And look there, north-facing slope, receiving sunlight. Now I will know which side of the mountain receives the highest temperatures. It is obviously going to be side A, because side B is our shadow zone that does not receive sunlight for most of the day. So a question that initially looked very, very daunting, that I thought I would not be able to answer, just by thinking back. And remember, in Mapwork, you need to know grade 10 work, grade 11 work, and grade 12 work. Okay? The basics of climatology. In grade 10, grade 11, and grade 12, obviously next year you are in grade 11. Now, so A will obviously be our warmer slope. Why? Because it is the north-facing slope. It is the north-facing slope in the southern hemisphere. Let's move on. Earlier on, I spoke to you about rows of trees. Now look carefully at this picture in front of you. It is an orthophoto map. We can see it's an orthophoto map. It is not a topographical map. In other words, it is an aerial photograph that has contour lines superimposed on it. And when I look at this orthophoto map, I can see over here in the northwestern side, I can see rows of trees. All over, I can see rows of trees. Now, why on earth would a farmer take time to plant rows of trees? These are obviously not forests. These are not trees that are being grown for commercial purposes, because then you would have large plantations. You would have large areas covered in trees. So these trees are not being cultivated or grown for commercial purposes. So why are they there? Let's see if any of you can answer that question for me. Why are these rows of trees? No notifications coming through yet? Okay. I'll just move on. 3 reasons. First of all, it breaks the wind. Remember, at your farms, you've got these large open areas of land. Very often there aren't mountains, there are no tall buildings. When we're in a city, we have these huge buildings which block the wind. Out in the farmlands, out in the rural areas, we do not have these buildings. So farmers would often plant rows of trees as windbreaks. They block the wind to protect the more sensitive crops that are being grown, to stop the wind from damaging or destroying the crops. It also reduces soil erosion. In other words, the amount of soil being blown away by the wind is greatly reduced when rows of trees are being planted. A reason that I just thought of now that is not on this presentation. Very often when farmers, if you're driving down the N1 or the N2 out of Cape Town, I'm speaking from a Cape Town perspective because that is where I live. And when I drive out of Cape Town along the N1 or the N2, farms adjacent to the National Freeway often have rows of trees all along the border of the farm where it meets with the freeway. Why? To block the noise. Can you imagine living on that farm and all these cars and trucks barreling by all day, all night? The noise would be quite terrible. So often trees are grown as a barrier, as a buffer to block the sound of the traffic as well. And then lastly, for aesthetic purposes, what does that mean? It means that it looks pretty, or it looks nice. Okay, it looks nice. We can see the trees, and it just makes the entire area look nicer. So they are also planted for aesthetic purposes. And I see that someone here who did not send their name says it can be used as a fence. That's one that I didn't think of. Okay, I wouldn't technically call it a fence, but maybe along the border or the boundary between farms, farmers would plant rows of trees to signify that this is where the one farm ends and that's where the next farm starts. So good thinking out there, anonymous contributor. Right. Mining activities. So we're still sticking with our primary activities. We are still sticking with our primary activities, but we are now going to look at mining. So, relatively simple. I think all of you can see in this area already. All of you can see in this area already what I'm going to ask, right? And the question would be something simple like, how do we know that mining is taking place here? Or what indication is there that mining is taking place in this area? Let's start at the top. Diggings. What does diggings mean? Diggings mean exactly what it says. People are digging. Obviously at the commercial level, so they'll be using large-scale machinery, there'd be huge holes in the ground if it is an open-cast mine, but people are digging to remove minerals or rocks, if it's a quarry, from the ground. There's also an excavation. The symbol for the excavation you will see once again on the key of your map. There's evidence of an excavation. There are conveyor belts because modern mines use conveyor belt to transport the ore. They don't immediately put it onto trucks. The ore is removed from the ground. It is dumped onto a conveyor belt, and the conveyor belt takes the ore out of the open cast mine to where the trucks are parked, and it is then loaded onto these huge trucks, and they are then taken away for crushing and smelting and the removal of the mineral from the ore. So, and then lastly, there's a slimes dam. Okay, ask your teacher to explain to you what the slimes dam is, but wherever you have a mine, there will be a slimes dam. And that is why you could also be asked, I don't have it on the slide, but you could also be asked to explain the effect of mining on the local area. And obviously, you're then going to be looking at things like air pollution, even though you can't see it on the map. We know that mines generate a lot of air pollution. Just the digging process, the dust that is generated. Mines also contribute a lot to water pollution. Now, grade 11s, notice I'm speaking about specifically air pollution. I'm speaking specifically about water pollution. You cannot in the exam just say it will cause pollution. You will not receive any marks. When it comes to pollution, you need to be specific. You need to state air pollution, water pollution. Give reasons why. The mine will generate a lot of dust, the digging, the excavations and the diggings, and that will add to air pollution in the area. The water that is being used during the mining process, which is then pumped into the slimes dam, can soak into the ground and contaminate the groundwater supply, or it could seep into rivers, into adjacent rivers or dams, and it could then contaminate drinking water supply. So those are all problems that could be caused. So once again, remember, we are looking at how your content that you've been learning during the course of the year can be tested in a Mapwork paper. Also, not shown on this map, but also look out for mine dumps, old mines that have been abandoned that aren't being used any longer, evidence of subsiding ground, sinkholes, etc. You will see that on the map, and then also for old mine shafts. And all of that will indicate you that mining is taking place in a particular area. Let's move on. Now we're going to go to a bit of geomorphology. And the diagram in front of you is very, very familiar to you, right? In term 2 of this year, everything that is on this diagram you've learned. You know what a plateau is. You've learned, your teacher has taught you how a plateau, through the process of erosion, gets reduced to a mesa, how the mesa is reduced to a butte, and a pointed butte until eventually you have a conical hill, which is reduced to badlands and then a flat plain. Now, how does this relate to map work? Very easy. This is actually the easiest part and the most common section to be tested in the Mapwork paper. Let's have a look. There is a picture of a mesa. Most of you have probably seen this picture of Tafelberg in the Karoo already. This picture is in a lot of the textbooks. So, here is a photograph. And on the right, here is an excerpt, a screenshot from the topographical map of this area. Notice the flat top. Let's have a look. Steep slopes. We know that the characteristics of mesas and buttes is that they have extremely steep slopes, and then they've got this flat, hard layer of caprock at the top. And when I look at the topographical map, doesn't matter from which side I approach it, a steep slope, the contour lines being very, very close together, and then at the top, hardly any contour lines, my contour lines far apart, which indicate to me that it is flat at the top. So you could be asked in the exam, identify the feature that this set of contours, that this contour pattern represents, and we know that it is a mesa. How do I know it's not a butte? Because the flat caprock at the top is rather big. If it were a butte, it would be much smaller. So, once again, there's a photograph that many of you are familiar with. There's a photograph of teerbus and koffiebus also in the Karoo. And when I look at this, I can see that I have a butte and a pointed butte. Here's a butte. It is smaller. It's a pity that we don't have a mesa in the picture to give us perspective, but this is a butte. Take my word for it. And this is a pointed butte. Notice how the layer of caprock at the top has been reduced to just a little point. And as it states clearly here, when this caprock is eventually removed, I will have a more rounded top, and it will then be referred to as a conical hill. Let's go and look at our map. Koffiebus, steep sides, flat top. Teerbus, steep sides, and just the point in the middle. Next year in grade 12, your teacher is going to teach you about the radial drainage pattern, but I won't comment on that now because you would not have been taught that work yet. So I can identify a butte and a pointed butte on this topographical map. Right, in addition to horizontal layers, we also look at inclined layers. Right, and this drawing and this sketch should be very, very familiar to you. This is of the Magaliesberg. And when I look carefully, I can see that on the one side of this ridge, I have a gentle slope. It is gentle because it is a more resistant layer. It resists erosion. So therefore, the slope is not very steep. It is not worn away easily. And we call that the dip slope. And on the other side of the ridge, notice how steep the slope is here. It is steep because it is a softer layer and erosion wears it away much quicker. And that is called the scarp slope. Have a look at the map. Can you see the dip slope and the scarp slope? Notice on the side, contour lines relatively far apart, showing me the gentle dip slope. On this side, contour lines close together, showing me the steep scarp slope. Dip slope, contour lines far apart. My scarp slope, the contour lines are relatively close to one another. And that shows my inclined layers. And here, obviously, we are speaking about things like Hogsback ridges, cuesters, etc., that you've learned about in the section on inclined layers. Now, learners, both with the horizontal layers and the inclined layers, You can be asked to identify them on the map, but you could also be asked to explain how they are formed. So you need to become prepared to this exam. You need to be able to explain how a mesa was formed, or how a butte was formed, or how a cuesta was formed. What can cuestas be used for? What's the economic importance of cuestas? All these things you could be asked in your paper 2, in your Mapwork paper. Let's move on. You've also learned about massive igneous rocks. Now, these are not easy to identify on a map. So usually you will be told on the map, this particular feature is a batholith or a lapolith or a laccolith or whatever. You'll be told that what the feature is, and then be asked questions on it. So I'm not going to dwell on this slide, because everything on the slide you know already. My focus is on map work. You need to know how granite domes are formed, and you will see now why I'm referring specifically to granite domes. Once again, I'm not going to comment too much on what you see in front of you. You need to know the process of how the batholith, which is formed beneath the Earth's surface, eventually becomes exposed at the surface and is then known as a granite dome. There's a picture of a good example here in Cape Town, Paul Rock, which is a granite dome. And just as a matter of interest, because of its rounded shape, the indigenous Khoi people called it Tortoise Mountain. I'm not even going to attempt to say Tortoise Mountain in the Khoi language, because I'll just make an idiot of myself, but take my word for it, it was called Tortoise Mountain. Now, just bear Tortoise Mountain in mind. Here we have a map of Paul, and the heading you see is intervisibility. And in your mind you're saying, but this man at the start said, we're not going to be doing calculations. And intervisibility is a map skill. It's not technically a calculation, but it's a map skill. But what I want to do with you now is just to show you how that Paul Rock, how my granite domes can tie in with the calculation section of the work. Right. So we have a school over here. And I want to know, from the school, can I see Paul Rock? So there's a blue line running from the school to Paul Rock. What you need to do, if you ask the question like that, can you see Paul Rock from the school? Just draw a line. Then you take your finger and you move along that line and ask yourself, are there any features along this line that are higher than Paul Rock? And obviously, if there are any features along the line that are higher than Paul Rock, you won't be able to see Paul Rock. You can see him at the moment because between that camera there and me, there's nothing in the way. But if someone were to move that large board across, you won't be able to see me because the board will be blocking your view of me. Similarly, if I look at the map again, between the school and Paul Rock, there is absolutely nothing blocking the way. The school is at 180 meters above sea level. Paul Rock is 543.1 meters above sea level, and nowhere along that line is there anything that is higher. See that? 180, 200, 300, 400, 543. So Paul Rock is visible from the school. It is visible from the school. Now on the other side, you will see Gordon's Rock. If I'm standing at the dam, Nantes Dam, which is at the height of 600 meters, can I see Paul Rock? Look carefully. Gordon's Dam, 600 meters. Paul Rock, 543. And you will notice between Gordon's Dam and Paul Rock, there's another rock called Gordon's Rock. Between Nantes Dam, and Paul Rock, there's another rock called Gordon's Rock that is 654 meters. See that? It is in the way. So there's no intervisibility. I will not be able to see Paul Rock from the dam because of this huge Gordon's Rock that is blocking my view. So Paul Rock is not visible from the dam. Right. There's a picture of it. There's a little man standing at the dam, looking in the direction of Paul Rock. He cannot see it because of this massive igneous rock, this batholith that is blocking his way. So there is no intervisibility between Nantes Dam and Paul Rock. Right. Grade 12s, we've technically come, sorry, grade 11s, I'm so sorry. We've technically come to the end of the Mapwork section. But I've put in just a few things that you need to know that would have been done towards the end of your geomorphology section that you could be asked on in the Mapwork paper. Highly unlikely. From this point onwards, it's highly unlikely that you're going to be tested, but you could be asked, right? You need to know the slope elements. You need to be able to identify your crest, know what the movements are along the crest, your free face, your talus or scree slope, and your pediment. You should be able to identify them on a topographical map using the proximity of the contour lines to one another to tell you the different elements of the slope. Okay? Mass movements, very difficult to test in a Mapwork paper, but what you could be asked, you could be shown a very, very steep slope in a very flat area, and you could be asked where would mass movements more likely take place. And obviously, you're going to be looking at the steeper slope because there'll be a faster movement of material down that slope. Then, a very, very beautiful picture taken along Chapman's Peak. Once again, highly unlikely, but you could be asked because you could be shown a very steep slope on a map once again along a coast like Chapman's Peak, for example, and you could be given a multiple choice question. I would, for example, ask which mass movement would be more likely to take place here, rock falls, mudslides, etc. And then you could also be asked which measures could you put in place, to protect people along the way. And we can see that here along Chapman's Peak, a canopy was built. Right, this is one of many canopies. I think there are about 3 or 4 along Chapman's Peak Drive that were built as concrete. So as the rocks come falling down the mountainside, they will land on the top of the canopy and safely fall over the side without harming any of the motorists along the way. There's another canopy. And then also those catch fences that were built to catch the rocks and to stop them from falling onto the road. Right, grade 11s. We have now come to the end of this section. There's a minute or 2 left, and I just want to use this time to tell you to please study. Spend as much time doing your geography. Obviously, you're not going to neglect your other subjects, but a good rule of thumb is to intersperse your work, right? So you're going to study a little bit of geography, and then you're going to study a little bit of mathematics. Then you'll study a little bit of geography, and then you study some life science. Then you study a little bit of geography, and you study some physical science. And in that way, you will ensure that all your subjects are covered. Remember, most of you shy away from the Mapwork paper, but Mapwork is actually the easiest section. Why do I say that? Because in your Mapwork paper, all the answers are in front of you. Everything that you need to know is on the map in front of you. It is just up to you. It is just up to you to look at the paper, look at the question, ask yourself, first of all, what am I being asked? Then go to the map. Focus only on the part of the map that you are being asked about. On which side of the mountain is it warmer? Focus on that little section. Where is it going to rain more? Focus on that section. Right? Focus on the section that you are being referred to. And if you do that and you look, you will find the answer. Make a list of possible things that you think could be correct. And then use your knowledge, what you've studied for paper 1, use what is in front of you on the map and try to find proof or evidence to prove the points that you've identified. And in that way, you will be successful. Don't forget to use the key at the bottom of the map. Don't forget to use the terminology that has been translated for you. And if you do that, I guarantee you that you will achieve success in your Mapwork paper. And remember, in your final exam, your paper 1 is 225 marks. Your paper 2 is 75 marks. And most of the time, you should be able to score a higher mark, percentage-wise, for your paper 2 than for your paper 1. So, grade 11s, I wish you well for your final exam. This will be my last time with you for this year. Work hard, and I hope to see every single one of you in grade 12 next year. Thank you very, very much. Enjoy the rest of your afternoon.